This is the last section in Chapter 3 and a second method to find the solution for a system of equations. But before we can get to that, we need to talk about inverse matrices and how to find them. So we're going to specifically look at just inverses of 2 by 2s. So if I want to find the inverse of a matrix, I am going to first, on the left to right diagonal, switch the order and then make the other diagonal negative. Okay, so I'm going to flip the 3 and the 5 and then make the 2 and the 8 negative. And then I also need to multiply this matrix by 1 over the determinant of the original matrix. So to find the determinant, we're going to have 3, 8, 2, 5. And remember, we do left to right diagonal multiply, which is 15, and subtract from that the other diagonal, which is 16. Oops, forgot the 1. So that gives me a determinant of -1. So I have 1 over -1 times this 2 by 2 matrix. So the inverse matrix is -5, 8, 2, -3. I want you to try B in a second. Okay, we're going to do C to C because it says specifically in what an inverse matrix is in the definition that your determinant cannot be 0. So let's take a look at one that happens. So when I start this one, I'm going to flip my 9 and my 4, and I'm going to make the 12 and the 3 negative. But when I find the determinant of the original, I have 4 times 9, which is 36, minus 3 times 12, which is also 36. So if I tried to do that, I would have 1 over 0, which is undefined. So this one has no inverse. Okay. So now that you've seen these two, I want you to try B for yourself. Alright, so we can then determine whether two matrices are inverses of each other if, when I multiply them, I get out what we call the identity matrix. And the identity matrix simply means that if I were to multiply a 2 by 2 matrix by this identity, I would just get the exact same identical matrix out. So if I multiply two matrices and they give me out the 1, 0, 0, 1, they are inverses of each other. So I'm going to multiply the 3, 2, 4, 3 times 3, -2, -4, 3. So remember, we use the rows in the first one and the columns in the second one. So to find my row 1, column 1 space, I'm going to use row 1, column 1. So I'm going to do 3 times 3 is 9, plus 2 times -4 is -8. Okay. If I move over to the first row, second column, I'm going to use the first row again, but use the second column. So I have 3 times -2 is -6, and 2 times 3 is 6. Row 2, column 1, use row 2, column 1. So I've got 4 times 3 is 12, plus 3 times -4, which is -12. And last but not least, row 2, column 2, 4 times -2 is -8. 3 times 3 is 9. So I do, in fact, get out 1, 0, 0, 1. So these ones are inverses. Okay, I want you to try the second one. Are they inverses of each other when I multiply? If I don't get the 1, 0, 0, 1 out, they are not inverses. Alright, so getting closer to solving a system of equations, if I want to know what matrix I need to multiply this 6, 8, 2, 3 by to get out 4, 3, 0, -2, we need to solve this equation. So in order to solve this equation, in order to divide, quote-unquote divide by a matrix, we're going to call that the same as multiplying by the inverse. So if I can find the inverse of this matrix in front of the x and multiply it by the 4, 3, 0, negative 2, I will get out the matrix for x representing a matrix. So I'm going to start with finding the determinant of the original. So I have 6 times 3 is 18 minus 8 times 2 is 16. So I get a determinant of 2. So I have 2. Remember, we want to flip the 6 and the 3. And we want to make the 2 and the 8 negative. And I'm going to multiply that by the other matrix. 4, 3, 0, negative 2. Okay, so if I carry that 2 through to the first matrix, I've got 6, negative 16. Oops, that should be 1 over 2, excuse me. Okay, so I have the 1 over the determinant, so I have 3 halves. Was that negative 4, negative 1, and 1/2 times 6 is 3. I'm going to multiply that by 4, 3, 0, negative 2. So I get 3 halves times 4, so that's 3 halves times 4 over 1 plus 0, negative 4 times 0. Okay, that's your first space. Then I'm going to do first row, second column, so I'm going to have 3 over 2 times 3 over 1 plus negative 4 times negative 2. Okay, and then bottom left is row 2, column 1, so that's negative 1 times 4 plus 0, because it's 3 times 0. And then negative 1 times 3 plus 3 times negative 2. So let's see what we've got here. So that's 12 over 2. That's 6. 9 halves minus 8. We'll deal with that in a minute. And then negative 4 and negative 3 plus negative 6 is going to be negative 9. Okay, so this is going to be a plus 8 because it's negative and negative. Okay, so we have 6, negative 4, negative 9. So I'm just going to kind of go off to the side for this piece here. So that's 9 over 2 plus 16 over 2. So that gives me 25 over 2, or 12.5. Okay, so again, I carried this 1 over 2, that's the determinant, the 2 is the determinant, 1 over 2, and I carried that into the flipping around of the stuff in this first matrix and multiplied it by what's on the other side of the equal sign. And that gives me what matrix I should multiply the original one by on the left side in order to get out what's on the other side of the equal sign. So I'd like you to try B. Alright, so now that we've seen a little bit of that, now we're going to look at solving systems of equations. I'm only going to do the 2 by 2s by hand. When you come in next class, we will do the last example that has 3 or more variables to solve for, and I'm going to show you how to do this on your calculator. So to start, to set up, I'm going to use a coefficient matrix for matrix A, okay, then times x by y. I'm just breaking this original system up into matrices in order to solve. So I'm going to set this up as the coefficients x, y, and then x, y times the matrix of x, y equals my solution. Oops. All right. So in order to undo this multiplication, I need to multiply by the inverse of the 4, 3, 3, 2. Okay, so I'm going to have your x comma y is equal to 1 over the determinant, so that's 1 over That's 1 over 8 minus 9, so that's negative 1. 1 over negative 1, flipping the 2 and the 4, making the 3's negative, and then I'm going to multiply that by 5, 4. You could technically do the multiplication first and then carry through the stuff on the outside. That's fine. So I'll do it that way for this one. So to multiply, I get 2 times 5 is 10, plus negative 3 times negative 4 is negative 12. Okay, and then for the bottom one, since this is a 2 by 2 and a 2 by 1, I'm going to get out a 2 by 1. So I've got negative 3 times 5 is negative 15, plus 4 times 4 is 16. So I basically have negative 1 times negative 2 and 1. So I get out 2, negative 1. So that means my point of intersection that had already learned how to do algebraically is 2, negative 1. Okay, so I want you to try this second one and save the rest of them. So all of example 5 is going to be done in class. And you're going to try this one. Alright, so I'm not going to have this one come up as a pop-up. Here is the worked out solution for this particular one. So I'm going to set it up as 3, negative 4, 5, 3 times xy is equal to 2, 13. Okay, so the determinant for this matrix, 1 over 9 minus negative 20, so it's going to be 1 over 9 plus 20. Flip the 3's, which they just stay the same, and then take the opposite of those two, and I'm going to multiply it by 213. So I've got 1 over 29 times 3 times 2 is 6, plus 4 times 13, which is 52. And then negative 5 times 2 is negative 10, plus 3 times 13 is 39. Okay, so I've got 1 over 29, so that's got 52, plus 6 is 58, divided by 29 is 2. And then 29 divided by 29 is 1. So my point of intersection is 2, 1. So again, we will look at how to do these on the calculator and continue with the bigger ones for sure on the calculator in class.